I have 3 files here that were part of a recent investigation. All of these were staged as scheduled tasks or auto runs or startup entries that would automatically run when your computer turns on or a user logs in. It's meant to be persistence for a threat actor, hacker, adversary, whatever you might like here. Now, all of these seemingly are placed in C Windows System 32. I've just created them as files here so we can poke and play with them. But on the file system, they were inside of the root of the operating system, right? So it's interesting because that leads me to think, oh, maybe they were already admin. They had write access and permissions to actually stage files inside of this privileged directory. And obviously all of them end with a .ps1 file extension, and they are PowerShell scripts. So let's take a look and see what is in each one of these. I'll go ahead and cat out my C Windows System 32, and let's start with that AB95 whatever and cat that out. This is what we have to work with. We have a random variable. You can tell it's a variable by the $ at the start being set equal to a script block type. Now we also have an alias here, a PowerShell alias ICM with some inside code and wrapped within parentheses with this object, the type script that was created, and then it ends up doing something with regular expressions. Regex you can see as another type here with right to left, for each mexed in the middle of it all, and all of this. So all of these scripts here, all of these different files have this very, very same syntax. If I try to cat out what will be the next one, that was what, a 1379, whatever, the exact same style. Another one I think started with A, is that right? Yeah, exact same style. Different variables and different inner code that it ends up working with, so let's try to take these apart. What I'll do is I'll open up my Sublime Text editor, and I guess we can start with that A691 value or whatever here. Now this opens up, and I want to turn on word wrap so we can actually see everything here, and what I'm going to do is I'm going to start to split on these semicolons. I do want to replace every single semicolon with another semicolon in a new line. Actually, I'll add an extra new line there. I am using Control-H to enter, find, and replace within Sublime Text. I'll hit Control-Alt-Enter to replace every single entry and occurrence, and now I have these at least split up, but really there's only 2 lines as part of this. We create this object, and we can basically just call this script block, right? So we'll replace that, and now we create a string where we join together some values, GP and ICM. Now, each of these are PowerShell aliases, so I can go back to my terminal. I'm inside of Remnux right now, and I can just use PWSH to open up PowerShell, the cross-platform, hey, my PowerShell core that will still run on Linux. Looks like there is a new version available, so I should probably upgrade it and do that just as well. But let me take some of these PowerShell aliases like ICM and GP and figure out what they are. You can do that with the get alias command line, or the alias to that is gal, and we'll just paste in ICM. Looks like that is invoke command. Now, we've seen a whole lot of invoke expression, but invoke command is super duper interesting because it'll actually work with built out objects, PowerShell objects defined as a script block. And that still creates syntax like code to be able to be ran and executed. I'm curious what this GP value is though. Let's try to do the very, very same gal or get alias on GP. That is get item property. Okay, so we're piecing together some portions here. Let's replace these, invoke command and get item property. Now, we also have some other symbols that are being used as part of PowerShell. This %sign is another alias for a for each object or whatever, however that for each is defined in PowerShell. We can just do another for each. And let's start to break this up a little bit visually. We know we're going to end up using get item property from some regular expression seemingly that they map together with right of left. They do a for each loop where they grab every single value as part of it and then they join that all together. Ultimately, they'll end up appending on some other random value and piping it to another for each where it just puts all of these characters together. And it closes all of these inner nested parentheses, whatever, one way or another. So you can probably already identify that this is HKLM or HKLM as the HKey local machine inside of the Windows registry. It's just backwards. And that's why that regex is included with this right to left property. Because if I were to just copy this, would I actually be able to run this within PowerShell and see it return that value out? Looks like I'm missing a parentheses, so let me add that on. And there we go. Looks like we actually have all of these values split one character at a time, and that might be why they joined them all. Yeah, you can see we broke it up here. That's why they end up using this for each to be able to return every single value for every single occurrence. So we can cut that piece and then see how they append and on a new value here. So let's grab that one more time. Okay, I've added and removed a couple of these parentheses, and I actually removed the dot appending value to it here. And so when I run this, I do get HKLM software, 7-zip, zfair, whatever leet speak there. But it will ultimately append and add on that PKN, ziv, and z, blah, blah, blah. So our original full string is this, right? This registry value that we end up probably get item property out of so that we could retrieve a registry value. Get item property will end up retrieving that value, then we combine it all together with another for each, and this is passed to invoke command, which has built out this script block. So this is one different way to still build out the IEX or invoke expression that we've commonly seen across tons and tons of videos, lots of different weird PowerShell samples. But ultimately, this will end up retrieving and trying to run code based out of the registry. So let me go bring this back to its original form and see if I can run it and see an error that could come from this, and that's exactly the case. Because I'm in Remnux, right? Because I'm in Linux, it cannot find this drive. A drive with the name HKLM does not exist. Of course, we don't have the Windows registry, so it's not going to be able to actually pull this down. But we've at least got that assumption correct and our good understanding. Let's see if we could find out what is in those registry values. Let me exit out of PowerShell and note again, if we took a look at all of these PS1 files, the PowerShell scripts that are found in sort of a fake stage temporary directory under C System32, they're all going to end up pulling from HKey local machine to find a registry value and then end up executing it with this technique. So, hey, thankfully for us, I have gone ahead and retrieved all of those HKLM values. This one was our 7-zip culprit, compal d whatever, and maybe a mozilla.org random stuff to try and blend in, right? With software installed on the machine. Real quick, before we go too far further, please allow me to give some support and love to today's sponsor of this video, Snyk. I'll be honest, I write bad code. Even though I try to hunt for vulnerabilities in lots of other software, I still have vulnerabilities even in my own projects. Everyone does. And that's why I use Snyk to scan for vulnerabilities in code, dependencies, containers, and configuration files. And Snyk helps find and fix those vulnerabilities in real time. You can try it and see for yourself. You can sign up for free with my link below, import your repositories, and sit back and let Snyk do the work for you. It'll find the flaws and vulnerabilities in your own applications. Check out this prototype pollution vulnerability that Snyk uncovered. We can see more details about the code path that introduced this vulnerability, and even learn more about this kind of vulnerability or any others if you check out the Snyk Learn lesson. I've referenced the Snyk Learn lessons and their vulnerability database a ton, especially in assessments and penetration testing, and even during Capture the Flag competitions. From there, you can see an explanation of the flaw, proof of concept exploit code and attack demonstrations, and most importantly, how to mitigate this vulnerability. But the best part? Snyk helps you fix this vulnerability with a single click. It'll automatically open a pull request so you can just merge and move on. So seriously, check out Snyk. It's crazy how many vulnerabilities could be affecting your projects and you don't even realize. Take advantage of their resources and learning material and learn all about the different vulnerabilities out there. It's completely free and you can sign up right now with my link in the video description. Huge thanks to Snyk for sponsoring this video. So let me open up our HKLM 7-zip, and this is exactly what we'd expect to see, right? Base 64 or whatever. I think the way that we end up pulling this value down, it is just encoded in base 64 for the sake of being able to grab all this data. And this is the value that we would have seen referred to. So I have retrieved this, and we can take this base 64 and try to decode that base 64. Let me save this. I'll go ahead and base 64 minus D, our HKLM software 7-zip, and spit this out. Looks like there's more PowerShell for us to work with. We'll go ahead and redirect that out to secondstage.ps1. And now let's go ahead and open up our secondstage.ps1. Interesting. There's like a random string here at the very, very top. But if you actually notice between all of the other HKLM values, notice how they all seem to have the same structure. This is the Mozilla one that I have open right now. But the very, very first line looks like it differs. Everything else seems to have the exact same data. I'll try and zoom out and actually make these relatively viewable. Take a look. Presumably same exact ending, same exact syntax for the whole rest of it, but the very, very beginning is different. If we wanted to base64 decode all of these, I'm sure we'd find the exact same syntax with just a different sort of like string ID at the very, very top of our second stage. We can do that super duper quick just to validate. Okay, now I've created these files next second and other second. We'll open these and take a look. It is seemingly the exact same thing. This one looks like it's broken. This one looks like it like missed a trailing like single quote, but obviously, hey, the whole rest of this looks like the exact same code. Do we have the same exact number of lines? Yeah, about 84 for each. Okay. So let's whittle this down to our very first one that we started to work with, and let's see what they do here. I'll full screen this. We don't have this string of text even run or execute or do anything, but we do create a new memory stream. We define a Microsoft function that can take in different parameters like Windows or Linux, and we try to resolve a DNS name passed in to the Windows argument. We could probably rename that to like first arg, because I'm assuming Windows isn't going to do anything other than match what the Microsoft little stupid name is meant to be. And then we end up retrieving the text record with DNS and trying to cruise through it. We end up using some more converting capability with this right to left syntax again. We use our for each value join get methods 3. What the heck is going on here? Let's turn word wrap on so we can see that full little line there. I'm curious what this might end up returning, but it ultimately is based off of the DNS record that we get back. So that probably isn't something we can drill down into right now. Position and right, though, all seem a bit interesting. I'm curious what DP is supposed to mean when MS or is our memory stream that we've created. So something that will end up probably being invoked in memory, right? Convert right to left. Maybe there's going to be converting base64 out of this. We'll have to, or bits, right? We'll have to come find out. Later on in the function, we do something with some crypto scheme, a RSA. We have a new byte array that we import as a blob, verified data, and I don't exactly know a whole lot about that, so I'm not going to pretend like I do, but interesting, is it like a signed signature thing? Probably. Curious, do all of the others have the exact same RSA component? Yeah, they all start and end the exact same way for that byte array. That's kind of interesting. I wonder if it's using like, hey, just some key to be able to retrieve the next payload. Anyway, we'll keep scrolling down. It looks like we have a while true loop, so this thing must be kicking off and trying to do everything that it can. Well, we have an array defined with a timestamp and text, and then for each C in com XYZ, for each A in wmail, Pharaoh, Bidu, private proxy, Ahura video, endpoint blog, chat, blah, blah, blah. Okay, so we're staging what looks like a domain, because ultimately this will end up being like a, I don't know, wmail-endpoint.com with all these put together in this whoa function or variable, right? And then row, if this wasn't already confusing, we'll use Microsoft whoa. I say the weirdest things when doing these kind of videos. And that will ultimately end up using this DNS name, trying to retrieve a text record from the DNS entry, and then doing something with it. Do we ever invoke this memory stream? MS. We ultimately take the timestamp if it has changed, if we add a new result, and then end up modifying the array part of that. If there is a value, looks like we do something. We do a script block create, and then co.text. So it will execute something that came out of the DNS record that it's pulled from any of these domains. This is like DGA, right? Domain generative algorithm, in a weird, stupid, primitive way, because it's like using this hard-coded list of values and then being able to create a domain out of it in some stupid PowerShell here. Then it sleeps for 35 seconds and loops again. So it's going to be continuously reaching out through each of these and then grabbing a domain text record based off of DNS, right? So let me actually steal this syntax. Let me modify this so I can just spit out each of these domains, because I want to be able to actually see what they are. So let me do a for each, close the for each yet again, close the for each yet again. There are a lot of tabs in this. What the heck? After we've built out all of these, let's create our whoa function. And now I should be able to just slap this back into PowerShell, right? And it'll spit out all of these domains for me. I'll paste all this in here, and there we go. Now I have all of the list of potential domains that it will end up reaching out to over DNS. This would all probably be stuff that's worthwhile to add to your firewall. Block all of these. Nothing good can come of this. Now let's see if we could actually retrieve some data out of one of those. I don't know. Let me exit out of this, and let's see if I can use dig for a text record on a horror video cdn.xyz, right? Nothing there. Okay. We could probably go through any of the others and see if any of them are still live. At this point, hey, I've spun up a proxy and not doing anything super shady. Forgive me. Let me go ahead and copy these, and I'll actually build these all out within Sublime Text. I'll use a dig tact text records, and then I'll grep for text at the end of each to see if I can only retrieve the line that might have something, right? That should be what I want. Okay, now let's stage all this. wmail.blog.com is taking a little bit of time to respond. That one's probably down. I should probably add like a timeout to these too. Timeout, 2 seconds? How about that? This might still take forever, and I have no idea if we'll actually get any hits whatsoever, but it's worth a try. Some things have some stuff. A lot of these are like SPF seemingly records, though. None of those look like PowerShell syntax. VSPF tac all, that's not helpful. Yeah, I don't think any of these actually have worthwhile next stage payloads, unfortunately. That's a bummer. It would have been fun to drill down into this a little bit more, but our work might not yet be done. I suppose we could probably Google for any of these or see if any of those domains are known bad. What's one that's seemingly pretty worthwhile? WMail blog, WMail chat. I'll go ahead and Google rather than actually entering that in my URL address bar, and let me paste that in. How to remove wmail.chat. That's not what I am looking for. A couple Dumbo malware tips. Malwarebytes has got some entry. Found the script in C System32 folder. Ooh, Spiceworks. What you got? Found the script in C Windows System32. Any idea what it does? March 2nd of 2023. Okay, that's actually relatively recent. They use XOR. That's interesting, but still pull out of the registry key. What does everybody say? Okay, yeah, they cut it up. They try to retrieve the registry values. Yeah, it's pretty sketch, right? I'd recommend a full virus spyware scan on the system. Might have something else there. Yep. PowerShell's being blocked from the firewall, identified as malicious, don't have a sandbox. You can post the string. What does that return? Look, anyone can run this. I mean, if you actually wanted to pull out the registry key. Ooh, look at this. This is like the exact same thing. Function get updates. Ooh, different, same sort of ID value. Interesting. So same like family of malware, same sort of strain. And they've pulled it all out. Same exact DGA, or domain generative algorithm, right, to be able to build out the same DNS text records, checking all of the exact same URLs that we have just seen. Oh, and some people got some entries. Some people actually got some strings out of this. We could play with those. We could totally play with those. Well, they're like all a mess, though. All right, we should table that for the moment. I do want to keep reading, but it looks like some folks passed it to ChatGPT. Okay. Thanks, ChatGPT. It's totally PHP and not PowerShell. Quick heuristic, Google some of the URLs, malware tips. I think we had pulled that one up, but this Pluribus one is new. And that's the end of that article. We could probably play with some of these text record responses, though, from some of the older URL responses. I'm curious what each of these might come back with. Let's grab this whole blob and then try to cut this up. Echo this into base64 minus D. What the heck? What is the rest of that? Replace every single literal period with a new line. What? What? Is that supposed to be there? You are lucky I saved you from becoming a victim of asshole malware. Clean your device now. Diarrhea to all coin stealers. Earn your money, you puppets. Was this in an actual DNS response? Did it like get clobbered by someone some way, somehow? What about all the others? The others are probably not just plain text base 64, right? What? It is. It's just PowerShell. Okay, so let me start at the top. Echo this to base 64 minus D. What? Now this looks wrong. How about this one? Okay, that's a real line. This is nonsense, right? That's the hello line. This is the other. So something else got in the way. I don't know. But this is just haphazard. This is not everything by any means, because this is all only what that person was able to retrieve from a couple of these endpoints. So that's not super duper helpful. But they did reference this other link that would be worthwhile to look into. Here, Pluribus 1, AI and Cybersecurity Insights. Ooh. Detecting PowerShell CryptoStealer attacks by a DNS traffic analysis. Main goal of cyber criminals can be described in one word: money, or just any criminals, right? Okay, cyber criminals working on the virtual side of the world represent the biggest threats to internet users. In this article, we will dive into one of the relevant threats that we're currently tracking by means of passive DNS analysis, PowerShell CryptoStealer attacks. Since June 22, okay, this article came out in August of 2022. Okay, so about a year ago, almost. Our DNS detector highlighted a cluster of public suffixes that you can find, like top-level domains, relatively high number of IP address sources, or potential victims. Example is provided below. Ooh, and these are the exact domains that we were just seeing within that PowerShell sample. Using the associated domain names as a search engine query, we found interesting hits on an Australian discussion forum. Oh, no. This is from June of 2022. Okay. CMD that always starts on my computer. Weird auto run. Again, pulling with script block. Odd that it pulls it from a file system this time. File on disk rather than registry. Digging into it all. Looks like people are trying to explore this together. Interesting. Some other scheduled tasks. The same sort of task ID name that we kind of seen previously. That's a bit odd. How have none of these actually found? Okay, here we go. CyberChef. Yep. Exact same endpoints that we saw. Ooh, they actually go to some specific location. Like they request it from the webpage. So that's not DNS this time, right? They were just using HTTP. I used Postman to formulate a request to send it to one of the domains and got a PowerShell codes as expected. Based on my limited knowledge of PowerShell scripts, I think this thing searches for the path of Chrome-based browsers and tries to steal access to crypto wallet extensions like MetaMask. I uploaded the code to Pastebin. Ooh. Okay, so there's probably not a whole lot for us to like dig further into here, but we can at least see the code that's interesting. Meta request version, GUID IP address, and the endpoint that we would have seen. Created new mutexes. Blah, blah, blah. Adding in a new assembly, creating functions to do WMI stuff. That's interesting. Get AV status, get install status. Okay, and here we go. Looking under different search paths that they've defined as lists and entries, creating some specific search entries like Exodus, Atomic Wallet, Electrum, Ledger, Jax. Oh, Bitcoin, Binance, of course. Okay, yeah. Yet again, CryptoStealer, MetaMask here and there, all over the place. Get apps is going to look for Chrome, Brave, Microsoft Edge. User info is going to end up using that WMI function to be able to retrieve specific WMI objects and then just kind of do regular enumeration, right? Then it does its get updates over and over again and just does its thing. Where does it upload this? Where does it set updates? Another script block? How does it upload these? How does it exfil all the info that it's stolen? Oh, post, of course. Okay. Here's the post asynchronous and just spits it over with JSON. Anyway, let's get back to this article that we were chatting about all this. Here's the syntax that they shared that we just saw on the Australian discussion forum. Of course, chatting about the DGA, domain generative algorithm based on the hard-coded word list that we saw. They referenced the Pastebin site that we just uncovered and then taking a look at all of these domains within VirusTotal. I'd be super interested. Now that this has been a year, have these got a little bit higher risk on VirusTotal? Let's search for the Ahura video blog. 19. Okay, looking a lot better. Wmail service, Wmail Schnell private proxy. How about that one? Also 17. Feru endpoint, about 18. Looks like a lot of these are significantly better than what they were, at least getting in the 18s, 19s, 17s-ish. Okay, I don't know if there's a whole lot more to dig into, but man, that was quite the rabbit hole between, look, the scheduled tasks, auto-run services that we might have started with, the PowerShell script that would stage with some invoke command and script block that ultimately pulls from registry to be able to get a secondary payload, retrieve things from a DNS text record, and then seemingly end up being a crypto stealer or info stealer. And look, man, PowerShell always being used for weird, shady stuff. But I've never seen like a crypto stealer in that shape. So that was kind of a neato. If anything, there was a really, really funny DNS entry that was weird, and I didn't expect that. But I hope you enjoyed this video, hope you had fun, hope maybe you learned something new, and if you did, please do all those YouTube algorithm things, like, comment, subscribe, and I'll see you in the next video.